What if I told you that right now, as you're watching this video, there's no such thing as above or below your head in space? Your whole understanding of up and down is about to get flipped, twisted, and completely blown away. See, here's the mind-bending truth. In space, there is no up or down. Earth isn't sitting on some cosmic shelf. We're floating in a three-dimensional void, where every direction is just a direction. But wait, it gets weirder. Our entire solar system is tilted at a crazy 60-degree angle compared to our galaxy, the Milky Way. Imagine riding a tilted merry-go-round that's on another spinning platform. That's us. So what exactly is above and below our solar system? Buckle up, space cadets, because we're about to journey through invisible force fields, ancient ice balls, and into the mind-blowing void between the stars. First stop on our cosmic tour, the heliosphere. This is like our solar system's personal force field, a massive bubble blown by the sun that extends way beyond Pluto. The sun is basically a cosmic leaf blower, shooting out particles at over 1,000,000 miles per hour. These particles create the solar wind, which inflates this protective bubble around us like the world's biggest balloon. But here's where it gets really wild. This bubble isn't round like you'd expect, because our whole solar system is zooming through space at 515,000 miles per hour. Our heliosphere gets squished into a shape more like a cosmic comet. Scientists used to think it might even have a long tail stretching out behind us, but new data shows it's more like a croissant. Yes, our solar system is protected by a giant space croissant. You can't make this stuff up. Voyager 1, humanity's most distant spacecraft, finally punched through this bubble in 2012 after traveling for 35 years. It's now in interstellar space, the void between the stars where our sun's influence fades away. But wait, there's more. Way beyond the heliosphere, starting at about 2,000 times Earth's distance from the sun, we find the mysterious Oort cloud. Imagine a giant snow globe the size of, well, it's hard to even comprehend. The Oort cloud is a sphere of trillions of icy chunks left over from our solar system's birth 4.6 billion years ago. These cosmic ice cubes are so far away that sunlight takes over a year to reach the outer edge. If Voyager 1 keeps going at its current speed, it won't even reach the inner edge for another 300 years. The outer edge, that's possibly 100,000 times Earth's distance from the sun. Nearly halfway to the next star. We're talking distances so vast your brain literally can't process them. And get this, the Oort cloud doesn't spin in a nice flat disk like the planets do. It's a giant sphere surrounding us in every direction, like we're living inside a massive cosmic bubble wrap. These icy wanderers sometimes get knocked loose and become the long-period comets we see. So when you see a comet, you're looking at a time traveler from the edge of our solar system that's been frozen for billions of years. But here's where your mind really gets blown. Ready for this? Our entire solar system, including that massive Oort cloud, is just a tiny speck in our galaxy, the Milky Way. We're located about 27,000 light-years from the galactic center, riding on what's called the Orion Arm. Imagine being on a cosmic carousel horse, but the whole carousel is one of billions in an impossibly huge amusement park. And remember that 60-degree tilt I mentioned? Picture holding a frisbee at an angle while riding that carousel horse. That's how our solar system is oriented as we orbit the galaxy. We're not just sitting still either. Oh no, our entire solar system is screaming through space at 515,000 miles per hour, completing one lap around the galaxy every 20-30 million years. The last time we were in this exact spot in the galaxy, dinosaurs were just starting to appear on Earth. Talk about a long road trip. We've been traveling for millions of years, and we're still in the same neighborhood. But what about straight up from our solar system's North Pole? If you could travel perpendicular to our planetary disk, you'd head toward the constellation Draco, where there's absolutely nothing special. And going down through the South Pole, you'd head toward the constellation Dorado, which is equally unimpressive in terms of cosmic landmarks. Space doesn't care about our human need for significant up and down directions. So what's really beyond our solar system in every direction? Interstellar space. A vast emptiness with just a few atoms per cubic centimeter. It's like, imagine the emptiest thing you can think of, then make it 1 trillion times emptier. The nearest star system, Proxima Centauri, is 4.2 light-years away. If our solar system was the size of a quarter, Proxima Centauri would be another quarter, 500 miles away. That's like the distance from New York to Detroit. And our Milky Way galaxy, it's just one of at least 2 trillion galaxies in the observable universe. We're a planet, in a solar system, in a galaxy group, in a supercluster, well, you get the idea. The local group contains about 80 galaxies, with our Milky Way and Andromeda being the big kids on the block. And yes, Andromeda is heading straight for us at 100 kilometers per second. But don't panic, we've got 4.5 billion years to prepare. Beyond our local group, the Virgo supercluster, containing thousands of galaxies spread across 110 million light-years. And that's just our local cosmic neighborhood. But here's the ultimate mind-bender. Even above and below our galaxy don't mean much. Galaxies are oriented every which way in space, some sideways, some tilted, some upside down relative to us. There's no cosmic right side up, and the observable universe, it's a sphere centered on Earth. Not because we're special, but because light from beyond 13.8 billion light-years away hasn't had time to reach us yet. Every single point in the universe could consider itself the center of its own observable universe. So in a way, everywhere is the center, and nowhere is the center. Try wrapping your brain around that. What about the cosmic web? Galaxies aren't randomly scattered, they form massive filaments and walls with enormous voids between them, like a cosmic foam that extends in every direction. These cosmic voids are mind-bogglingly empty regions hundreds of millions of light-years across. Imagine driving through a desert where the nearest gas station is. Actually, there's no comparison. These voids make any earthly desert look like Times Square. And if we zoom out far enough, even these massive structures start to look uniform in every direction. The universe on the largest scales looks the same above, below, and all around, what scientists call the cosmological principle. So what have we learned on this mind-blowing journey? First, there's no universal up or down. Those are just conventions we made up because we live on a spinning ball with gravity. Second, our solar system is surrounded by invisible bubbles and clouds that dwarf anything we can imagine. The heliosphere and Oort cloud are like cosmic armor we didn't even know we were wearing. Third, we're part of a tilted disk flying through a galaxy that's flying through a cluster that's flying through, you get it. We're on the universe's most extreme roller coaster, and there's no getting off this ride. And finally, the universe extends incomprehensibly far in every direction from us. Above, below, sideways, it's all just more universe, more galaxies, more wonder than our brains can process. The next time someone asks you what's above the solar system, you can blow their mind too. Tell them about the cosmic croissant protecting us, the ancient ice storage facility, and our tilted joyride through the galaxy. Want to explore more mind-bending space facts? Hit that subscribe button and ring the notification bell. Check out our playlist on things that will break your brain about space. And visit nasa.gov for even more cosmic craziness. Until next time, keep looking up or down or sideways. In space, it's all amazing. The Cartwheel galaxy we mentioned earlier has an absolutely massive black hole at its center, about 100 million times the mass of our sun. That's like having a cosmic vacuum cleaner that could suck up our entire solar system and barely notice. Scientists recently discovered that the magnetic field lines in our local bubble are incredibly complex, twisted like cosmic spaghetti by all those ancient supernova explosions. We're basically swimming through a bowl of magnetic past. The James Webb Space Telescope has been making incredible discoveries in both these directions. It can see through cosmic dust better than ever before, revealing baby stars being born in regions we thought were empty. It's like having cosmic X-ray vision. In the direction of the North Galactic Pole, Webb has discovered that star formation is happening in incredibly thin streams of gas, like cosmic rivers flowing through space, creating stars along their banks like celestial cities along a cosmic highway. And here's something that'll make you question everything. The speed we're moving through the local interstellar cloud means that the particles hitting our solar system today actually started their journey before human civilization began. We're literally being bombarded by prehistoric cosmic dust. The temperature of the local interstellar cloud is about 7,000 Kelvin. That's hotter than the surface of most stars, but it's so incredibly thin that if you could stick a thermometer in it, you'd freeze to death while it reads extremely hot. Space is weird. Recent studies have found that our journey through different parts of the local bubble may have influenced the evolution of life on Earth. Different cosmic ray levels could have caused genetic mutations, literally helping to shape what we became as a species. The Hubble Space Telescope has been studying the motion of stars in the Coma Berenices region for decades, and it's discovered that many stars are moving in weird directions, like cosmic traffic that doesn't follow the galactic speed limit. Down in Sculptor, astronomers have discovered what they call dark galaxies, massive collections of dark matter that barely have any visible stars. It's like finding cosmic ghost towns that are there but almost impossible to see. The collision that created the Cartwheel Galaxy wasn't just a gentle bump, it was a high-speed cosmic crash at about 1,000 kilometers per second. That's like two freight trains colliding, except the trains are entire galaxies and the crash site is 500 million light-years away. Scientists estimate that our local bubble connects to other bubbles through cosmic tunnels called chimneys. We're literally living in a cosmic subway system where hot gas flows between different bubble stations. The Sculptor galaxy is so active in star formation that it's creating superstar clusters, groups of stars so massive and bright that each cluster outshines most entire galaxies. It's like having cosmic spotlights that are visible from millions of light-years away. Here's a mind bender. The radio waves from the Sculptor galaxy that we detect today actually started their journey when the first dinosaurs were evolving on Earth. We're literally listening to Jurassic space radio broadcasts. The recent discovery of the Radcliffe wave shows that nearby star formation isn't random. It follows a massive wave pattern that stretches for thousands of light-years above and below our galactic plane. We're riding a cosmic tsunami of star birth. And in a final plot twist that'll leave your brain spinning, recent computer simulations suggest that our solar system's path through all these cosmic environments might not be random. We might be following invisible galactic currents like a cosmic Gulf Stream. Here's another incredible discovery. The Gaia Space Telescope has mapped the exact 3D positions of over 1 billion stars in our galaxy, and it's revealed that the local bubble has actually compressed and stretched different star-forming regions like cosmic silly putty. Some stellar nurseries have been squashed flat while others have been stretched into cosmic taffeta. The European Space Agency's Planck satellite discovered that the cosmic microwave background, the afterglow of the Big Bang, looks slightly different when viewed through our local bubble compared to other directions. We're literally looking at the beginning of the universe through a cosmic lens. Recent studies have found that the Parker Solar Probe, as it travels closer to the Sun, is detecting particles from the local interstellar cloud that have actually made it past our heliosphere's defenses. We're getting cosmic postcards delivered right to our solar doorstep. And here's the ultimate mind blow that connects everything we've discovered. Scientists now realize that the ancient supernovas that created our local bubble didn't just happen randomly. They were part of a massive chain reaction called the local bubble complex that includes multiple connected bubbles spanning thousands of light-years. We're not just in one cosmic neighborhood, we're part of an entire cosmic metropolitan area, with interconnected districts, each shaped by stellar explosions happening in precisely the right sequence over millions of years to create this incredible cosmic architecture that we call home. So when you think about what's above and below our solar system, remember this: we're not just floating in empty space, we're passengers on a cosmic journey through an active, dynamic, interconnected neighborhood, full of explosive histories, star-making factories, galactic crashes, invisible highways, cosmic silly putty, and universal lenses that connect bubble cities across the Milky Way. Want to explore more cosmic mysteries that'll bend your brain into a pretzel and make you question everything you thought you knew about space? Subscribe for more mind-blowing space adventures that'll turn you into the ultimate cosmic tour guide. And remember, every time you look up at the night sky, you're not just stargazing. You're looking out the windows of our cosmic neighborhood as we cruise through galactic suburbia at 26 kilometers per second, surfing waves of ancient starlight through a universe that's way stranger and more connected than anyone ever imagined.